Hello, my name is Chen Lingzhan, and in this video I'm discussing how I work to improve the performance and fit of my aggressor for the M3 final hackathon. So focusing on the Airbnb dataset, I will cover two main areas: what I did to improve the performance of the regressor and how I assessed the improved the fit of my model. So to improve the performance of my regressor, I focused on the several strategies. The first is the model selection. I started with the simple baseline model, the random forest regressor, which is robust and handles both numerical and categorical features well. It also helps avoid overfitting to some extent due to ensemble method. The second is the feature engineering. I explored the dataset carefully and identified key features that would be predictive. I used the techniques like one-hot encoding for categorical features such as room types and neighborhood groups, and scaled numerical features like price and square footage. Third one is a high parameter tuning. I turned hyperparameters of model using research CV and realized the search CV. I especially focus on optimizing the numbers of trees in a random forest, the maximum depth of each tree, and the minimum samples required to split internal nodes. This allowed me to find the best combination of parameters for the data. And fourth is the assemble method. After achieving a solid baseline performance, I experimented with boosting models like XGBoost. I found that boosting significantly improved performance by focusing on hard to predict examples in each iteration. This helped reduce bias and the variance. And the fifth idea is the cross-validation. I use cross-validation to better estimate the performance of my model and reduce the risk of overfitting. And I employed five-fold cross-validation to ensure my model would generate well on the test set, preventing any data leakage. By combining this strategy, I was able to increase the accuracy of my regressor, minimize RMSE, and ensuring that the model performed better on the cargo leaderboard. The part two, so the assessing and improving fit. So to assess and improve fit of my model, I took several steps. First, learning curves. I plotted learning curve to evaluate how my model performed as more training data was used. This helped me understand whether the model was underfitting or overfitting. If the model was overfitting, I noticed that the training error will be lower than the validation error, signaling that I needed to adjust hyperparameters to prevent overfitting. Second, residue analysis. I analyzed the residues to assess the fit of my model. I plotted the residues against predicted values and observed whether there were any symptomatic patterns. So the third is model complexity. And the fourth, I also considered adjusting the complexity of my model. Initially, my random forest model had too many trees, which made it quite complex and prone to overfitting. By reducing the number of trees and limiting the maximum depths, I was able to prevent the data model from becoming too complex and better capture and underlying trends in the data. The fourth is the validation matrix. Besides RMSE, I also used other validation metrics like R-squared to assess the proportion of variance explained by the model. This helped me ensure that my regressor wasn't just minimizing RMSE, but also capturing meaningful patterns in the data. So through this method, I was able to ensure that my aggressor was well-fitted and didn't suffer from underfitting and overfitting, ultimately improve both performance and predictive accuracy. So in conclusion, I focused on improving my model's performance through carefully feature engineering, model selection, hyperparameter tuning, and some using assemble techniques like boosting, and then assemble and improving the fit by using learning curves, residue analysis, and validation metrics, ensuring that my model was well generalized and capable of making accurate predictions. Thank you for watching this video. I hope these insights provide us clear understanding of how I approach to the problems, improve the performance of my regression.